Good day everyone. In our previous lecture, we discussed about the role of ESC in a drone. Once we have understood the importance of ESC, let us look at the factors which decide on the selection of ESC. In our current lecture, we will decide how do we select an ESC for a drone. Let's look at it in our further slides. There are various factors that determine the selection of an ESC. Factors are given as follows, which are current rating, size and weight, battery elimination circuit or BEC, thrust requirement, motor size, and propeller. Let's look at these in detail in our next upcoming slides. The first thing to look at when choosing an ESC is the current rating, which is measured in amperes. Motors draw current when they spin. If you draw more amperes than your ESC can handle, it will start to overheat and eventually fail. Catastrophic failure can even end up with your ESC in flames. Three things that tend to increase your current draw and put more stress on your ESC. First one is high motor kV. Second is larger motor size. And third is heavier propellers. There are two current ratings to an ESC, continuous and burst current. Continuous current rating indicates the maximum amount of continuous current which the ESC can safely handle. Even when racing, it is unlikely that you will use maximum throttle for extended period. ESCs are usually designed to withstand a higher current for short periods of time, example 10 seconds, and this is the burst current rating. Sometimes beginners confuse the current rating of an ESC as amperage that it would apply to the motor, but the opposite is actually the case. The motors that draw current to the ESCs, so the ESC must be rated for maximum amps of the motor you are using. The weight of the ESC is dependent on the current rating of an ESC. Most ESCs on the market today have more or less similar dimensions and weight rating, between 4 to 5 grams each. It's challenging to make ESCs any lighter without having to lose performance and effective cooling. Though lighter is better for racing, it is not wise to bargain on one of the most important components of a quad. Smaller ESCs heat up quickly and cannot be effectively cooled without constant overflow over the ESC. Even though the smaller ESCs carry heat sinks, they are not enough in most of the cases. BEC stands for Battery Elimination Circuit. The function of a BEC is to provide constant current at a specific voltage. Airplane ESC usually have BECs as they provide power for the plane that are required for the electronics. But in the world of quads, we really don't need ESCs with BEC, as the power necessities like powering a VTX or powering a camera is taken care of by a dedicated power distribution board. The EEC lacking a BEC tends to be much less noisy, lighter and smaller in size. The thrust produced on a motor is dependent on the ESC itself, as an ESC is responsible for spinning the motor. Two different ESCs can produce different amounts of thrust with the same setup, that is, same motor and propeller. This is mainly because of the quality of components used on the ESC. The difference in the thrust produced can vary as much as 20% between a good ESC and a cheap knockoff. The thrust can also depend on factors such as belt quality, quality of solder joints, and various other. Another factor that could affect an ESC is its size. Smaller ESCs have smaller heat sinks, which do not cool as effectively as their larger counterparts, and hence result in poorer efficiencies. A hot ESC performs poorly than a well-cooled ESC. The quality of a solder joint also plays an important role in the thrust produced, as a bad solder joint may limit the amount of current flowing through it. But the latest ESCs from reputed manufacturers perform very similarly with very little difference in the thrust produced. The size of the motor will greatly dictate the amount of amperage your ESC must be able to handle. Choice of propeller will also dictate what amp rating your ESC should be. Will your drone be spinning 3, 4, 5 or 6-inch propellers? What kind of performance will you want? And therefore, what kind of propeller pitch will you use? Let's say, for example, in drone racing. Modern racing drones are nearly all using 5-inch propellers with a high pitch. For these high-pitched propellers to spin at high RPM, pilots will select a motor with specifications such as 2207, 2450 kV. This motor, with an aggressive pitch prop, can pull upwards of 40 amps. Therefore, selecting the right ESC is important so that the ESC doesn't get damaged in the mid-race. Therefore, it is a good idea to design your drone for your specific need and application. Selecting an ESC for voltage, however, is much more straightforward in that ESCs have ratings on them indicating the battery voltage they can handle. Generally, for a 4S drone running a 5-inch propeller, an ESC capable of 30 amps sustained current will work for nearly all applications like freestyle and racing. To summarize, the following factors were discussed during the lecture, such as current rating, size and weight, battery elimination circuit, thrust required, and the motor size and propeller. Once we have selected the ESC and motor, we need to test them to make sure the setup is ready for our drone. In our next lecture, we will discuss about the testing of the motor and ESC and how do we test our setup before flight. Thank you very much.